Okay, hi guys. In this video, we will discuss about losses in transformer. Okay, before this, we assume the transformer is ideal, so there is no losses. So in this part, we learn about practical transformer. Okay, practical transformer. Practical transformer, they have losses in a few losses in practical transformer due to wire. This wire usually made by copper or aluminum, so there will be resistance there, then there will be losses due to this wire type, copper or aluminum. And also we have a magnetic core, so there will be losses in this magnetic core. The magnetic core, they have two losses of magnetic core, Eddy current loss and also hysteresis loss. Due to this magnetic core normally made by iron, so iron, they have losses in iron, or sometimes made by ferromagnetic, so that type of ferromagnetic of iron, they have their own resistance, they have their own magnetic domain in this iron. So that's all contribute to the losses of the losses in transformer due to this magnetic core. And also we have at the secondary part, we have a wire. This wire, normally this wire made by copper or aluminum, so there will be losses in this wire and this coil, this winding, there will be losses due to this winding, and we call that one is flux leakage. Okay, leakage here and here, flux leakage here. Okay, so from this practical transformer, we convert to equivalent circuit diagram. So how to convert it? So let's say, okay, this one is, we have current I1. Okay, this case we assume no load here, no load transformer. So no load transformer, we have I1, we have I2 here, and also we have generated EMF at first coil, E1 generated EMF at second coil, E2. So this one is V1. So we just follow this construction. So we have resistor from this winding, so there will be R1 is primary winding resistance. Okay, and also there will, here we have coil winding, so there will be leakage flux through this winding. Okay, flux leakage, so we name as a inductance leakage flux X1, primary leakage reactance. Okay, here. Okay, then okay, the flux flow in this coil, in this magnetic core. This maximum flux flow through magnetic core, so there will be current, magnetizing current, we call that one is magnetizing current, and this magnetizing current cause a hysteresis loss, okay, due to energy used in orientating the magnetic domain. Okay, we have the magnetic domain here, this is iron core, so there will be magnetic domain here, so this energy, the energy used in the orienting the magnetic domain, so it will use to orientate the domain like this, so this energy will be losses. This we call hysteresis loss. Magnetic core, okay, losses of this magnetic core, we have one is hysteresis loss. Okay, magnetizing core. Another one is core losses. core loss. Sometimes we call eddy current due to eddy current loss. Okay, core loss due to RC. RC, the one is XM. Okay, XM is magnetizing reactance. RC is core reactance. So normally we call it I mu IC. This one is I0. Okay, this one is I1 here. I1. So lastly, this is winding, primary winding. Okay, primary winding. So E1 here, EMF, generated EMF at primary winding. Okay, N1, number of turn for primary winding. Okay, so V1 here. Okay, this is the equivalent circuit of the transformer, open transformer at the primary side. Okay, now at the secondary side, we have winding. So winding here, N2. Okay, when we from the Faraday's law say that the changes of flux here and presence of this conductor will produce magnetic reactance here. So we have magnetic reactance at the secondary side, X2. Okay, then this wire we have in the wire itself, the resistance of the wire itself, R2. Okay, secondary wire reactance. Okay, then this is our out, I2. This is V2. Okay, primary voltage, primary winding resistance, primary leakage reactance. I0 is null primary current. IC is core loss current, magnetizing current. XM is magnetizing loss, magnetic reactance. RC is core loss resistance. Sometimes we call eddy current. Eddy current loss. So this one is E1, E2. Generated EMF at coil number 1, generated EMF at coil number 2. Okay. Okay, I think that's all the type of losses. Okay, we can conclude that we have copper losses due to wiring. We have R1 and R2. Okay, this wiring and this wiring. So this wiring, they have R1. Second wiring, we have R2. Okay, copper losses due to this wiring. Second is losses the magnetic core. Losses magnetic core, they have two losses in the magnetic core: hysteresis losses and also eddy current loss. So hysteresis loss. Okay, this one is due to orientation of energy use due to orientation of magnetic domain here inside the core. Okay, rearrange. Arrangement of magnetic domain. Sorry. Okay. The arrangement of magnetic domain. Okay, energy use. The arrangement. Okay. Let's say this is our core. They have magnetic domain here. Magnetic domain like this, like this, like this. North, south, north, south, north, south. So when energy pump here, so this domain will arrange like this with the arrangement. Before this, the arrangement is just chaos. So the arrangement, the energy used to arrange the magnetic core here. Used to arrange magnetic domain. Okay. Sorry. Okay. Just remove. Third losses is eddy current loss. Okay, also same in this magnetic, they have size here. Okay, we have cross section of the core itself. This is cross section. This cross section, the size cross section of the core. Okay. This cross section produce losses. If we want to reduce the losses, we make it in laminated pieces, so there will be losses of eddy current loss. So fourth one is leakage flux. Okay, we have leakage flux here and here. X1 the primary and X2 at the secondary. Okay, I think we cover all the losses in the real transformer. Before this ideal transformer, so there is no losses. So now in practical transformer, there will be losses due to wire and due to magnetic core, and also wire. So they have two wire, so two winding losses and magnetic core losses. Okay, that's all. Thank you.